Okay, your augmented matrix for this system of equations is what? It's C1, what, sorry, 1, 0, 1, 0. Because the first column is your coefficients of C1, the second is your coefficients of C2, third is your coefficients of C3, and this is your right-hand side, right? So this stands for C1 plus 0, C2 plus C3 equals 0, which is this. Yeah, the orders are different, but you know, organize it. Okay? This tells you 0, 0, 1, 0. Right? And this tells you 1, 2, 0, 0. Okay? Now what's the augmented matrix for this one? Same matrix, or same square matrix, but you're augmenting it with A, B, C. Okay? And the matrix reduces so C1, C2, and C3 are all 0. It's not necessary to go to the augmented matrix here because it's real easy to solve this, you know, for this particular basis. Okay? Here. And you can this reduces to the identity, right? And what you get is A minus B here, okay? And you're going to get C minus A minus B over 2 here, and you're going to get B here. If everything I've done here is right. I didn't actually do that reduction. But if you start with this matrix and do the row reduction, you should end up with this one. If this solution is correct, and you can always check this before you go reducing that matrix and wasting your time. Or reduce the matrix, see if it agrees. If it doesn't, check your solution. And you can say, yeah, you were wrong. Okay. And, put a minus on that B, even though I had a plus here. Okay? That makes sense? So in general, if your augmented matrix of your coefficients, the augmented matrix you get, and what have we done here? Remember, this is just C1 V1 plus C2 V2 plus C3 V3 equals 0, right? And this is just C1 V1 plus C2 V2 plus C3 V3 equals AX squared plus BX plus C. Okay? So everything reduces down to matrices like we've been dealing with for 2 months. Okay? And matrix reduction, if you wish. Okay? Now we're going to make some big connections on Thursday with that whole thing. Other things we can say, your 3x3 matrix here has rank 3, nullity 0. Okay? Because rank and nullity are important. Okay? And if this wasn't true, if this doesn't reduce down to the identity, then you don't have a basis because you got a free variable in here. Since you have a free variable, one of your C's is not going to be 0. And that probably means the others aren't either. Okay? Does that make sense? That's all involved with rank, nullity, and a lot of other stuff is involved. And that's kind of where we go with this test that's coming up, okay? And if you understand everything that we've done, which didn't appear to necessarily be the case first time we did the test, hopefully that changes in the next week, okay? Then you should be able to pull this together into a good picture of what a vector space is so that we can go on to inner product spaces and linear transformations and eigenvalues. Okay? Those are the 3 topics we've got to get. We'll have about 5 or 6 weeks to get them. Okay? Okay. So, that's an example. Okay? Now, I'm not going to work in detail through an example with M32 or whatever, okay? But it works out very similarly, so I'll do one with, you know, I'll start an example, just to give you an idea where it goes, okay? Just so you can see the notation. But it all reduces to simultaneous equations, and simultaneous equations always reduce to augmented matrices. Duh. Which I've been telling you about now for 2 weeks, right? There's no duh about it. You can't be stupid and understand this, okay? You got to be smart and understand this. But y'all have shown me you're smart enough to understand it. Just hopefully you have time and everything else it takes, okay? Make sense? Okay, good.